You're going to hate me when you see this question. So an object is being launched. We like throwing things in math. We like things to go up and then come down. And then we want to do a bunch of parabola questions about that. The things we want to know when we're doing parabola questions is, where did something start? Like, at what height did I throw that ball up into the air and down? That's a popular question. What does that want to know? The y-intercept. Then the questions say, um, what height does the ball get to, or the rocket, or the soccer ball, or the frisbee, whatever's going up and down? What height does it get to? That's part of the vertex. What time does that happen? That's part of the vertex. And then the last thing these questions can ask for is, when does the ball hit the ground? That's asking for the zeros. So with one type of question, they can ask for a bunch of different things. And this question wants to know the first part, determine the maximum height of the object. Now, you are going some awesome math here. You even did the brackets correctly. This is looking solid. But guess what? It is all obsolete because they actually gave you the question to A. Sorry. They gave you the answer to A in the question. This is vertex form. If this is vertex form, that's the max. Therefore, max at 13.5 seconds. That's it. That is all this question is asking. So we have to know that when they're asking for the maximum, they want the optimal value or the y value of the vertex. Similarly, so I just said similarly, I pressed pause, I did some cutting and pasting, but I want to come back to this. So for letter A, I'm sure this is a 1-mark question. Determine the maximum height of the object. The max height is 13.5 seconds, and h is the height above the ground in meters. Good, 13.5 seconds. Oh, no, meters. Megan, you can't have a max height of seconds. It's okay. Stop day drinking. Oh no, I made 2 mistakes. No. This is gonna be meters. Then I don't like this. The length of maximum height. I don't I don't know what this question is asking. I have a feeling you found zeros, which would be really good to use if it said, when did the ball hit the ground? I would want to use the zeros. But I think what this question is asking, at what time did the maximum height happen? And if that's what the question is asking, we have to look back at the original equation, and the time that the maximum height happens is given right there. It's our h value. So I think this is asking, these questions usually ask for the h value. They want the vertex, they want you to answer the optimal value, they want you to answer the axis of symmetry, and then in C, they actually want you to answer the C, the y-intercept as well. So I believe that this answer is the, are we shooting a ball? The ball reaches a max after, if I'm wrong, I want you to double look at the language of this question because I need to know this better. That's not, something's off here. And it just might have been because you didn't know what it was asking. So you're like, oh, okay, well, the length that it was at the max height, and you wrote it that way. Um, but I don't want you to write this down if it's actually wrong. And then the last thing is the height of the object when it was launched. You did this work, believe it or not. All of this is the money ball up here. So I'm actually going to erase those because I've decided I want that. And we want the y-intercept. That's this value right here. So all of this work goes for C. For C. And then the original height, the height of the object when it was launched. So the original height of the window, because it was launched out of the window, therefore height of window is, I believe you had 9 meters. Now, does that make sense? Start off at, oh, you're going to watch me draw a parabola, a crooked parabola. Start off at 9, go up to 13, and then go down. Yeah, that makes sense. Yeah, this is happening at 13. This is how, oh, it's slanted. Look at how slanted it is. And then, so max height, 13.5, happens at 1.5. We shot the ball out at 9 meters. Okay, 13.5 meters, 1.5 seconds.